Alright, second video on random sampling, and we're going to look at things like statistical inference and random number generation. Okay, so far we've looked at the concepts. A population is a set of all relevant elements of a group, which we are considering they're all the ones that are eligible, basically. And next, a sample is a subset of population, as we said last time, which we select in order to make inferences. Now, there's a word I am guilty of not including in the previous video, but that's important. Inferences. We can deduce things and come to conclusions. Generalizing from the sample to the population will not be useful unless it's representative, and we talked about that last time. Okay, it's all in video 1. Now, the central query of inferential stats is we're looking at a sample and asking ourselves, what can we say about the population from which it was drawn? So we look at a sample, and what does that tell us about population? And the reverse, if we know what the population looks like, what should a sample look like? What should its characteristics be, and so on? Now, the difference between what's called a parameter and a statistic is important. A parameter is a characteristic of the entire population, whereas a statistic is a characteristic of a sample. Okay, and it depends what characteristic we're looking at. But here's a diagram. So this diagram is, we are looking at here the proportion of a certain number of a certain person with a certain characteristic in a population. It doesn't have to be that sort of data, but that's what it is here. If that's the entire eligible population there, it's of size capital N, as we said in the last video. A sample size, once we've taken a random selection, alright, it will have a sample size which we denote by a little n. This is the group that we can feasibly measure. We can get from there a statistic, okay, a sample proportion. And the statistic sample proportion is given the symbol lowercase p with the little hat on it, okay, and that's lowercase p. And population parameter is just lowercase p. Now that's the proportion of elements of that population that have a certain characteristic, what proportion they are, and the sample proportion is that sample of that have that characteristic in the random sample. Now looking at this one here, it looks like, just having a quick scan, it looks like roughly 5 out of 30, and that looks like about 1 out of 6. So that one's suggesting that yes, that sample is fairly valid because it reflects the greater population, okay, in its proportions. The population proportion, lowercase p, is the proportion of individuals in the entire population possessing a particular attribute or characteristic. Now it's considered constant, right? The sample proportion, p hat, is the proportion of individuals in a particular sample, okay, in the sample that produce that same attribute. And it will vary from sample to sample. That's significant there. So hopefully not too much, but it can vary, and sometimes it does vary significantly, and we have to consider that in all reality. So here's a little activity. Identify the following as either sample stats or population parameters. Okay, I'll just go SS versus PP. All right. So 43% of voters polled say they are in favour of banning fast food is the first one there. Okay. Now that's a sample because it's a poll. So it's a sample statistic, that one. Okay. Next one. Now that's a census. According to the ABS census data, the average family has 1.7 children. That's a population parameter because it's constant at this stage in time, at this era, okay, and it's across the whole population. This one here, 18 to 23% of Australians skip breakfast. That one's a little bit hard, but that seems to be an estimate about a population. All right, so that sounds more like a population parameter than it does a sample stat. Whereas this one, subtly different. 9 out of 10 is an exact value, and they're small integer values, so that does sound more like a, you see 9 and 10 are small, that does sound like, yeah, it's a small sample, and I'd say that's probably a sample statistic more likely. Some of them are a little bit harder to see, like the first two quite easy, that one reasonably easy, but C and D you know, you have to read into it a little bit there. Okay, but the first two are quite easy. All right, so that's a bit of a difference between PP and SS. Looking at ways sampling happens, we're going to, as you know, we're looking at random sampling, but there's systematic sampling, like one at the every 20th individual that comes along, for example. That can give reasonably valid results. There's stratified random sampling, where strata are subpopulations. Okay, so groups that are easily discernible in a larger population, that's strata. And then there's self-selected ones, which can be problematic. They can have issues with bias sometimes. Phone polls, because they're often people who agree to take part in the sample. All right, it's not truly random. All right, we're going to use random number generator now using technology TI-Nspire to select a group of 6 students from the following classes. Okay, now we've got 4 by 5, we've got 20 there. All right, we have to select 6. So what we want to do is assign a number to each of these students here, 5, 6, 7, 8, 9, okay, and I just go all the way up to 20, give everybody a number, all right, and then what we do is we get our TI-Nspire or equivalent technology. Okay, now we're going to generate 6 random numbers, and we can't have any repetitions because we can only select 1. We want to select 6 individuals, so we can't, let's say 11 comes up twice, we can't choose it twice, we have to choose another random number. So with our TI-Nspire, what we need to do then is go into the probability menu number 5, and then go to random number 4. And after we go to random, we want random seed to completely randomize our where our random number generation comes from. Now you can just put in 4 numbers from your telephone number, like the 4 last numbers, or your postcode or something like that. Okay, and then now you're ready for random selection. And so we go back into that same menu again, probability, random, and now we go into random integer. Now there's other ways of generating random numbers, but we're going to just focus on integers. And if we want from 1 to 20 inclusive, and if we want 6 numbers, we put in the parameters as such, and then we check, are there any, sometimes you get them repeated. Yes, 9 is repeated, so I'm going to repeat this and do it again. Now I'm going to take 9, 14, 1, 9. I'm going to skip the next 9. Did you see that? I'm skipping that 9. Alright, skipping it. Then I'll take 10, and then I'll take the first number from the next one, 11, because it hasn't been repeated. And that would correspond with the students I select there, and that would be my selection. How do you like that?